Good evening and welcome, everyone. So today we are going to continue our lab session, and we are still on EC2. We'll try and then finish this first part early, and then we'll look at auto-scaling, right? We'll try and then finish this session early, and then we'll look at load balancing and auto-scaling so that we can use tomorrow for another lab exercise on volumes. So for today's lab, there are a few things that have been provisioned for us already. So I'll first let us go into that and then check them out, right? Before we begin what we are supposed to do. Okay. So the first one is that there is a VPC that has been created for us already, or there's a VPC that is already created. So when I shared the message earlier, I highlighted that you need an understanding of VPCs, security groups, and then subnets, right? In order to appreciate today's section. So if you haven't, please try as much as possible to go back and refer to the previous session videos. So there is a VPC that is created for us, and that is the lab VPC. That is what we are going to use, right? And then within the lab VPC, let me just open it. Within the lab VPC, there are two subnets that has been created for us, right? Two public subnets that have been created, and there is an internet gateway that is also attached to it for security groups. I think there should be a security group that is also created for us as well. Great. So those are the things that I wanted us to appreciate before we go on to do what we are supposed to do today. Right? We all have the outline and then what we are supposed to do. Okay. Let me try and then go over it. So today we are going to launch a web server with termination protection, and then we are going to monitor the EC2 instance to get some understanding and then metrics from it. And then we will also modify our security group rule. We did that yesterday, but we are going to do it today as well. And then we'll manually resize our EC2 instance to scale. Kindly mute if you just join, kindly mute yourself. Right, so we'll resize our EC2 instance to scale, and then that's the manual way. And then we'll test the termination protection that we put on our EC2, and then we will now terminate the EC2. But then we will check what we call service code test, right, to check as to the limits that we can have per region using the limit of EC2 instances that we can have per region. Great. So can you please mute? I can hear some feedbacks from the
Ima, can you please mute?
Okay, thank you. Great. So to begin with, we'll create our EC2 instance. By now, we all know where to find the EC2 service and then launch our instance. So we are not going to take a lot of time. So I'll launch. No, Ima, that's fine. That's fine. So here we'll just name it web server. You can give it any name that you want, but I'll give mine web server. And we talked about tags, so the tag is the name. We are okay with that. And for the machine image, we'll keep everything as it is default. We'll use the T2 micro And for Keeper today, we are not going to SSH into it, but it is always like important that you use a Keeper. Okay, but there is a Keeper created also already. We know how Keeper is created. So we use the Keeper that is already created. Great. Now on network settings, as I said earlier, there is a VPC that's created for us. So we'll edit the network settings and then we'll choose the lab VPC. Okay. All right. So by default, we have two public subnets in this VPC. So we can either choose any of the subnet that we want to, put the instance into. But by default, it selects the public subnet one for us. And then for security group, yes, we'll create a security group. Okay. So we'll create, and then we'll give it a name, web server SG, right? That is the short name, like a short name that I would want to give it. And then I would say security group for, why is this in solo like that? Web server. Okay, so that is security group for web server. And then there is a security group that is there. I'll remove it, right? Because we'll modify this later. So we'll just remove the inbound rule. Okay, we'll just delete it. So we don't have any inbound rule, or we don't have any rule to this security group. And that is also allowed. We can just do it that way. For storage, we'll also leave it as it is. And we'll go to the advanced details. Since it is a web server that is going to host our application, we'll have to add a user data, right? A script. But we need to do something here. I said we are creating this with what? Termination protection. So we can also find it in the advanced details, right? This is termination protection. And then we are going to enable that. Okay, so we have termination protection enabled. This is something that we didn't do yesterday. So aside that, everything is okay. And then now we'll choose our user data script. So I have the script here. This is a bash script. Okay, so then yeah, I'll paste the script here. So it's just saying that, okay, write this script into this location or into this file, right? So this will be our bootstrapping script, the script that is going to run before, it will run once before the instance is fully booted. Okay. All right. So now launch our instance. But first, we just verify that if we are okay with whatever we have done. A VPC. Yeah.
So you see the bash commands.
Yeah. Are the listener or in network drop?
Sorry, So is it just going to drop an HTML page onto the Amazon server? The
Yes.
purpose of the code there.
Yes. So this is what is going to drop the HTML page onto the server.
Okay.
But this, you can actually like write the script, leaving this one out. Okay. So what this one is
So you
just
can literally copy an HTML script and come and dump it here.
exactly. So you can just install, after you install your Apache server, this is the command that will install the Apache and then start the service. It will enable the service and then start it ASAP. But
Nice.
you can just copy any other HTML script and then come and dump it below this one.
Sure.
Okay.
You can go on.
All right. So we can just launch our instance. And then view all instances. Okay. So once it's still booting, we can check some few details, right? We have to wait till we have 2 out of 2 checks for here, and then we can look at some 1 or 2 things. Okay. So let's hold on because we need some data here. So wait for a while. While we wait, if there is any question, you can please ask. Refresh. It is initializing. So you can see that immediately you go to the initializing, the system check from system status check changed to initializing, instance status checks also changed to initializing, right? We can also look at the monitoring tab. So we'll come here to check some metrics and then all that. But since it's not booted, fully booted, we still have to wait till we have the 2 out of 2 checks. Let me refresh it again. Let me refresh the page itself. Sometimes this console. Oh, still. Okay, so I think we still have to wait for some time. But whilst we wait, we can do these checks on this one, right? Let's just do that. So when I go to status checks, you can see system reachability check is passed. Instance reachability is also passed. When you go to monitoring, let's see. Yes, you can see that we have some data here. So we can just click on any of the metrics that we want to. So we are looking at the CPU utilization, and then we can enlarge it, right? So when we enlarge it, we are able to get like a full view of it. This is the same thing that we would probably like have on the other one that we launched. Let me close it and then check if it is still okay. So good. So we can go back to our own web server. When you go to status checks, you can see. So this is the 2 checks that it was doing, right? System reachability and then instance reachability. So this is just 2 checks. Okay, great. And then we can go to the monitoring and then see. We wouldn't have much of a data because we just launched it, but you can see some blue dots here. There are some readings here. Okay, that shows the percentage of the CPU that is utilized, network in bytes. We can also enlarge this one to see what we have there. So you can see it's just so the CPU utilization currently is what 0.54. Okay, 0.5. Let me put it that way. 0.5 thereabout. Okay, that's how can we see this one here. So for the in the monitoring tab, you're able to check various metrics, right, about your instance, and then you can look at it in a 1 hour, 3 hour, 12 hours, 24 hours, 72 hours, and then 1 week intervals. You can also set custom time, right? So I can check it in minutes by minute. So this is 1 minute, and then that is about the monitoring. You can also select, go to actions, and so you see monitor and troubleshoot, okay, and then get system log. Yeah. So here it gives you kind of a detailed breakdown as to when you spin up our EC2 instance, right? What was happening. So let me scroll to where it was bootstrapping. I mean, installing the HTTPD. That is the Apache. So you can see it here. You can see it started from here. Okay. And then you can see the package HTTPD. And then all the other utilities that it's needed. Okay. This is what was happening. And then we started downloading the packages. And then now it was installing. Right. So this is like a system log as to what happens in the back end. Right. When you started up your PC or you started up your EC2 instance. Okay, so the user data that we pasted, that was what it did. Okay. So after it was done, so this completes. Okay. And there were other things that it was also doing. And he said what the initialization finished the time that it completed. So if there was a problem, imagine let's say you try to access your Apache web server and then there's something wrong. You can come and check this system log to see where the problem was. Because if the process broke at a point, you'll be able to see it from here. So don't be actually be scared about all these plenty things. Whatever you are looking for, you'll be able to see it here. So if let's say the Apache server, in as much as it downloaded all the packages, okay, the installation, in case it failed at a certain point, you can see incomplete, or you can see whatever it is, the process will break. So you'll be able to see that, okay, this thing didn't successfully install. Then you just do the whole thing manually again. Okay, so that's another thing that you can also monitor. Okay. So I'll cancel this. And then I'll select the web server again. I'll go to actions, monitor and troubleshoot. And this time I'll do get instance screenshots. So this screen, okay, what you are seeing here is just showing you how your instance will look like if you had another screen connected to it, right? If you have a screen connected to it, this is how you are going to your instance is going to look like. Okay, it's a Linux server, so definitely you are going to read text by text. Okay, so you are just getting a screenshot of the instance itself. So if there's a screen connected, this is what you'll be seeing on the screen, right? So if in case you are not able to access your instance by SSH, okay, you'll be able to. This image is going to give you as to what is happening, the current status of your EC2 instance. So there you'll be able to see that, okay, there's something wrong. Okay, it's probably there is something that that didn't go well or something like that, right? You can also download the screenshots, for further investigation and then all that. So it's just different ways of you monitoring your server or your EC2 instance that you have launched, right? So you can get a system screenshot, you can get system logs, you can also monitor the metrics from the monitoring tab, right, under the details section. So now we are going to access our web server. I'll cancel this one, I don't need it. Okay. So another thing, yesterday we looked at how we can reach our web server through a public IPv4 address. So I can copy this IPv4 address and I'll paste it here, okay? And you will see what will happen. So you can see that it's still loading. By this time, if it is working, we should be able to reach it. Like immediately I press enter, we should be able to reach it, but we are not able to. So for me to be sure that we are really following, what is the problem now? We are not able to reach the server, and then you can say that this site can't be reached. The IP address took too long to respond. What is the problem? Let's see if everyone is following. What might be the problem, or what is the problem? Because normally when you spin up a web server, you should be able to reach the server through an IPv4, through the public IPv4 address, right? But this is the case where we are not able to reach it. It's just timing out. So what is the problem? Okay, so Luis, can I have like more people, just like how we answer the exam questions? Can I have more responses so that we do it together? We spin up a web server. On a normal situation, we should be able to reach the website or the web application through the public IPv4 address, but we are not able to. We are getting timeouts. What is the problem? Well, let me continue. So yes, as Louis said, this is a security group issue. Exactly. So it's here's a Jabine firewall. Great. So so that's like technically you have to check your security group. Okay, it's not about like accessing allowing public access, but you have to check your security group and then allow inbound traffic. And then if you can remember, we created a security group, but we didn't add any inbound rule. So you can see that there is no inbound rule here. Okay, so you can also look at that through the security tab from here. Okay, so when you go to security, you can see the security group that is attached to it, but there is no inbound rule here. There is outbound rule that allows all traffic to anywhere. Okay, but there is no inbound rule. And then we know that by default, if you haven't specifically allowed inbound rule, by default, it is what? It is denied. So I'll click on my security group here. Okay, and then I'll edit the inbound rule. So what rule are we adding? We are allowing HTTP traffic from anywhere. Then we save the rule. Okay. So without even going back to check anything, I will just refresh this page and then boom, it is access. I mean, it is working. If I should, let me remove the security rule, the inbound rule, save, refresh, and see that it is also stuck at the infinite loading and it will time out. Is somebody trying to talk? So you can see that it is timed out. If I should add the inbound rule again, add it back, HTTP, anywhere, save rule, and it's available. So that is also one thing to check out, right? When you are having, but most of the times, if you are not able to access your web application, then it has to be most of the time, majority of the time, either your server is not ready, like it's not done booting, or if it is done booting, then it is a security group issue. So you have to check your rules and then right. Now we want to resize our instance type. Okay, this manual, right? We want to resize our instance type and the volume that is attached to it. Okay, so let me go back to the EC2 instances. So I'll go to instances. First, to to do this adjustment or resizing, I will have to stop the instance. Okay. So I'll stop the instance. Let me wait for it to stop fully. Okay, so now it is stopped. And we're having T2 micro, right? When we started this, we had a T2 micro. We can check for the volumes, the storage, right? Let me see storage. And then the volume size was what, 8 GB. And let me go to the details. We'll see the instance type somewhere. Should be in the details here. If we don't see, we just move on. Okay, so yes, the instance type is here. You can see the instance type is what? T2 micro, right? So we are coming to change our instance type. So we realize that, okay, the T2 micro we even chose is probably small or too much, right? The storage might also be too small or too much. So we can actually change it, right? So what we'll do is we'll go to the actions, we'll select the web server, same here, and then we'll go to the instance settings, then change instance type. Yeah, so this is more or less like a vertical scaling, exactly. So we, instead of T2 micro, we want a T2 small, okay? So we have to go to the T family. Okay, great. And then T2 small. So we're having T2 micro. We are coming to T2 small. And then we'll apply. So for storage, the same thing. So select it again. Actions. I think instance settings. And yeah. Is somebody want to talk? We should have modify volume. If anybody sees it, kindly let me know why. Or let me see image template. No. That's instance settings. Modify volume, modify volume. Let me just go to storage. I can change it from here. Volumes. Yes, volumes. Correct. So I'll just go to the volumes from here. And we have two. Okay, so this is the one attached to our web server. The second one, so I'll select it this way. Actions and then modify volume. Great. So we're having 8 GB and then probably it's too small for us, so we'll change it to 10 GB. Okay, we leave everything as it is. Modify, modify. Great. So now we'll go to our instances. And now the next time that we are going to launch, right, or we start the instance, it is going to start with the changes that we made. So remember, we have changed the storage size from 8, right, from 8 GB to 10 GB. And then we have changed the instance type from T2 micro to T2 small, right? So instance states and then start.
Yeah, seems today you know use your account, your AWS account. You don't use the lab account.
Yes, and
I
they
come
can't play. And they can't,
$5.
and they can't play with volumes then. When it's an instance type, so I don't want any trouble. So I've started. It is initializing. Let's give it some time. We should see the changes effected. Okay, so even though it is not done, but we can see that the volume size has changed to what? 10. Let's go to the details and then we'll see that the instance type has also changed to T2 small, right? Now there is one thing. Okay, let's test the termination protection that we activated. Okay, they're still initializing. So let's go and explore some other things before we come back. Now, there is a quota or there is a limit for the number of instances that you can run in a region. Okay, and then there is a service that you can use to check that. And the name of that service is a service quota. Okay, so I can search for service quota. So we can see service quota, select that. And then we'll choose AWS services. And from here, I'll just search for EC2. Okay. So I'm a Elastic Compute Cloud. So there are other services that you can actually check, right? And then see the service quota or the service limits that you have, right? And then I'll search for running on demand. So running on demand. And here is all the on-demand like instances. Okay, the on-demand instances that we can launch. And then you can see from here, if you look at, you can see the applied quota value is what? 256. Okay, and then the AWS default quota value is 5. You can request. So you see there's an option for adjustability. So you can request for this default quota to be adjusted, but you can run up to a 256 on-demand, standard on-demand instances in North Virginia. Right, by default, you have 5. So if you want more, then you can request at the account level for it to be increased. So that is just about service quota. So you can there are a lot of other services that you can. So there's CloudFront. So these
So
are
if you ask the service quota, what does it do? Is it units? Is it credits? Is it the power? How powerful that service is?
so like
Can we break?
the number of times that you can run a particular service. Right. So if it is an EC2 instance, you cannot launch more than 256 EC2 instances in North Virginia.
Exactly.
Right. So it depends on each service, right? Each service and the quota that
The number of
yes,
services you can replicate.
you can replicate, yes, in one region. So that is just about the service quota. So you can use it to check those limits, right? And then you can also use that to check if there are ones that you can request for adjustment. Okay, but you can adjust to, there is still a maximum number that you can adjust to. Right. So that's basically on the service quota. That's a short one. So we'll go back to our EC2. We are coming to test the termination protection. Okay. So termination protection is just to prevent an accidental termination of your EC2 instance. Okay. It's just like you putting a deletion protection on your file so that immediately, maybe by accident, you delete a file. It doesn't get deleted, right? So I'll select this web server instance state and then I'll go to terminate instance. So you can see here that there is what termination protection enabled. And this is what we enabled when we were starting the whole thing of creating the EC2 instance. So if you click on terminate, what do we see? Fail to terminate an instance. the instance blah 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 may not be terminated. Modify its disable API termination instance attribute and then try again. So for us to successfully terminate our instance, we will have to change a setting, right? So we'll still go to action, instance settings, and then there is change termination protection. Okay. Click on click on that. So you can see it is enabled. I'll just disable it, save, and then still selected, go to instance state and then terminate instance. So terminate, choose successfully. So you can see it is shutting down. So our instance is successfully terminated. Please, any question? We want to move to auto scale, load balancing and then auto scaling. So if you have any question, kindly please let me answer before we move. Let me end this lab. Let me close it. So there are certain things that we will not repeat. Okay. There are certain things that we will not repeat. So I will just move to the auto scaling module so that some resources that need to be provisioned for us, they are already provisioned. So we'll just continue from there. All right. Please, is there any question, any confusion, any clarification that you seek before we move on? It doesn't mean that everybody understands.
I think you should restructure a question. Those who don't have any questions should type no in the chat box.
Okay, so how many of you have been able to like go through the previous video or tried to practice what we did yesterday? I know two people gave me feedback today. I know, okay, someone said you are a superb tutor.
Hey, Chema Bego. The last time I taught was in, I think, early 2000, 2003. Red Cross. That's the last time.
That be the compliment I get from someone to me. Is this thing ready? Sometimes it will just be stuck at this place. Anyway, so for the load balancing, this is what we are going to do. So as I said, some of the resources or the services have been provisioned for us. So we are just going to continue from a point. Okay. So we are starting with this architecture. By now, we all should be able to understand this architecture, but let me explain. So this is the AWS cloud, and this is a region. Okay. The blue here is a region. And then we have a portion that we have carved for ourselves. That is the VPC. So there is a VPC that has been created for us already, or there's a VPC that has been provisioned in this lab, right? And then it is a kind of a multi-AZ architecture. So AZ1 has a public subnet and a private subnet 1. And then AZ2 has a public subnet 2 and then private subnet 2. Okay. The private subnet both have security groups as a firewall attached to it, right? Protecting the Amazon database, right? An RDS is a managed service, so an RDS database. And in the public subnet, yes, the web server, that is the web application, is also resting there, which also has a security group protecting it, right? Acting as a firewall. And there is a NAT gateway that's attached to the public subnet to allow outbound traffic from the private subnet. And there is an internet gateway that is attached to the VPC to allow internet communication. So this is the architecture that we have met already. Okay. So this lab, the purpose of this lab is to, let me say, improve it. Okay. So we are coming to improve it. So to improve it, we'll end up this way. We'll set up an application load balancer to evenly distribute workload, okay, to our web instance, okay, in the private subnet. So it will evenly distribute the traffic, okay. And there is also an auto scaling group that will auto scale in case work demand changes or workload changes. Okay, there's also an auto scaling group that is going to do that for us. So you can see some orange EB right around these ones. So these are new. It's like these are new instances that has been spinned up in addition to what we have here. So this is by courtesy of what the auto scaling group. Let me zoom in and see, so that everybody will be able to see it well. So you see this one, what you are seeing here is by kind courtesy of the auto scaling group, right? It's by kind courtesy of the auto scaling group. By default or previously, this is what was there. And then now this has been added through the auto scaling group. And then the load balancer is evenly distributing the loads across, right? So I'll open my AWS. Oh,
No, click here.
yeah, I click save. Hmm. So first thing that we are going to do for our auto scaling group, we'll give the auto scaling group a template, right, to launch with. So like this one, you will go my accounting. So per the default architecture, this would have been the course that will incur like in the few minutes that will work. Anyway,
Two C, two C 50%. You won't cry.
right now I have 30 cents too. I get 30 cents we have for pay. Anyway, so we'll create a machine image, all right, for the auto scaling group to use in case they have to spin up an another instance when our workload changes. Okay, so we'll create an image from the EC2 instance that we have already or the web server that we have already. So I'll go to EC2, the same thing, go to instances. Okay, let me take this thing off. And then it's our web server. Okay, this is our web server is our web server that we are going to use. Okay.
Quick,
Yeah.
please. Did you? I thought I saw you end the lab.
Yeah, and I end up.
So how come the web server is still on?
I'll start another one.
Just right now.
Yeah, right, you know.
Oh, okay, okay.
Right. So this web server has been created already. Okay. We can also go through the details to appreciate what was done. So per the architecture that I explained, the VPC, the subnet that this server is in, what again? Let me go to security. Right, the security group that is attached to it, and then these are the inbound rules that is attached to it. So port 80 and then port 22. So that is SSH and then HTTP. Okay, there is an outbound rule as well. Great. So we are going to create a machine image, an image out of this web server, right? Just to keep whatever it is intact when, in case a new one is being spinned up by the auto scaling group or by the auto scaling service. Okay, and it also enables like a fast boot up process since everything is not going to start like afresh. So with the web server selected, I'll go to actions and then image and template, and I'll choose what? Create image. So I'll type a name for it. So I'll just say the web server AMI. All right. Web server AMI. web server Amazon machine image. And description, I'll just give it to lab AMI for web server. Okay. I'll leave this one as it is, the storage the same. Yes, and then the volume should be deleted on termination, and then I'll create the image. So I think yesterday and then day before, we mentioned that if you want your system to your boot up, your next boot up, or you want to replicate a server, the best thing to do is what? To create an image. So you set it up, do everything, install all the softwares and everything that you would want, and then you create an image from it, and then you can now replicate them. So the image is what I just did. Okay, you just select it this way whilst it is running, and then actions, you go to image and template, and then you create image, and that's just it. So the image is created. Where is it? We'll see it. All right. The next thing is to create a load balancer. For the architecture that we saw, looking at the architecture that we saw, okay, now we have our image there. Now we are coming to create the application load balancer to distribute the load evenly across the instances. So that is what we are coming to do. Now, to do that, we'll go to what we call target groups. We'll first create a target group. Okay. So I think that should also be here. Yes. So we see load balancing, and then we'll create a target group. So the target group, what the target group does is that you use it to group your instances. Okay, you use that to group your instances so that the load balancer is going to target that. It's just going to look at that. Okay, so if I want to distribute the load, I have to check this target group. You get it? Just point it to what to actually use to do. So it's just like if a policeman want to do scatter, where do they go? They'll go to the ghettos because they know that that is where we can find them. School, when your SHS is it academics, your assistant headmaster academics. Anytime they would want to do some operations, they will first check the corners that canteens that are out of bounds. That is where you are going to see most of the truants there, right? So that's basically what it tells the load balancer to do. So okay, hey, use this one to evenly distribute my load. Okay, so I'll create the target group. The target group should be what? Instances. Okay. So we can also choose IP addresses, a Lambda function, or even another application load balancer. Okay. And then I'll set the target group name as lab group. The protocol, I'll leave it as it is. The ports, I'll leave it as it is. For VPC, I think I will leave it. Yeah. Because that is what is there. Okay. And wait, they didn't give me a name for it too. Anyway, let me see. Okay, so there is a lab VPC. Let me check the architecture to see. Okay, so that is 10 or 16. Okay, so I'll use this one, right? This is what we used before, so I'll use this one. This one has to be the default VPC. So I'll use a lab VPC for this, right? And then from here, I think we are good to go. So instances, lab group, the address type, the VPC is the lab VPC. Good. I think we are good to go. So next, And for target group, the available instances, since we have not launched extra instances, so we'll leave it as it is. We'll leave it as it is. Yeah, we will not add any instances for now, because we are going to use an auto scaling group to, what's it called, create more instances. So if like we had all our instances created here, then I could have just selected it this way, okay, and then I'll register the target as include as pending below, okay. But since it is not it's just a replications of other instances, so we'll leave this one. We'll not register any instance here, and then we'll create the group. Okay, so now we have our target group created. The next thing we are going to do is now create the load balancer. So we'll go to load balancers. Then we'll do create load balancer. And then we are creating what? An application load balancer. So we'll go to create. And the name for the load balancer is lab ELB. Yes, it's an internet facing load balancer. We'll leave it as it is. For VPC, we'll choose the lab VPC. And then we have what? The two AZs. Okay. So we are good to go. Let me just select the two. And then we'll choose public subnet 1, then public subnet 2. Correct. So it will load balance or balance the loads to these subnets. For security groups, there is a security group that is created for us. So it's what? Web security group. Yeah, so here, okay, this is the web security group. So I'll choose the web security group. So I'll take off this one and then select the web security group that we have here. For listeners, so here, this is where it's going to forward the action to. Okay, so it will, where will it forward to? It will forward to the lab group that we created, the target group that we created, right? That is where this listener, so when the traffic is coming and then it is too much, it will forward the traffic towards the lab group, and then the number of instances that we have in this group, it is going to be able to distribute the load evenly. Okay, so once that is done, these are optional services that we don't need, so we'll review it. So the basic configuration is what? The name, it is an internet facing load balancer, and then it's using the HTTP protocol, right? So sorry, and the IPv4, and then the security group is the web security group. If we want to see what it is there, I can just click it and then look at the rules that are there. So you can see HTTP and then SSH. That is what it allows this traffic. And then we can also look at the network mapping. So the network mapping is in what? The public subnet 1 and then public subnet 2. Great. And then the listeners, what is it doing? It will listen on port 80 and then forward the load towards the target group that we created. So I'll create the load balancer. So view load balancer. So once it is provisioning, we'll now have to create our auto scaling template, right? We'll create a launch template for our auto scaling group. Please, are we following? And I'm your call fast. Tell me your call fast among and then I'll pause and then explain before we move on. So what we have done is we have the architecture there already. Okay, there is a VPC created for us. We know how to create a VPC. And there is a security group that has been created for us. We know how to create a security group and then attach it to a VPC. Now, we need a load balancer as well as an auto scaling service. To one, the load balancer will be able to distribute loads evenly, right? It will be able to distribute traffic evenly to our web server. And then the auto scaling group is just going to make sure that there are enough instances provisioned according to changes in what? In the workloads. Get it? So what we did first was to first create an image for our auto scaling. We just created an image for our auto scaling. So that was a running instance that was already running, and then we created an image out of it. The next thing what we did was to create a load balancer. And to create a load balancer, first you have to have a target group that the load balancer is going to forward load to. So the load balancer listens from a port and then forward the loads to that target group. So we first created that target group, and then we now created the load balancer, right, to forward load to that target group. So we are done with the load balancer. We are now left with the auto scaling group. And then for the auto scaling group, you know that since it is an automated service, we first have to give it a template that, listen, in case you are spinning up new instances, use this template. Okay, you are just giving it like is it a bench, a blue, oh, there is something is it guide? No, it starts with B. A blueprint, correct? You are giving it a blueprint to follow in case they want to launch, in case the workload changes and then they want to launch another instance. Okay, so that is what we are going to do. Anyway, so for that one, we'll go to launch templates. Good. And then we just click on create launch template. So for the name, I will say, I can just say auto scaling templates, anything, right? So lab AS auto scale. And then description, let me leave it. I think okay, but let me see. Launch template. Launch template for AS. Good. And then we'll select this one. So provide guidance to help me set up a template that I can use with EC2 Auto scaling group. And so for machine image, so remember I asked that the image that we created, where is it? So this is where we'll find it. So for machine image, we'll come to my AMIs. And then for owned by me, you can see the web server AMI that we created. You remember we gave it a name as what? Web server AMI. And then the description was lab AMI for web server. So ewaha, HDD. All right. So for instance type, now we'll say that, okay, you use the T2 micro. We have to make sure that it is in the free tier. For key, yes, even though we will not do SSH, but it is always important that you still give it a key pair. For network settings, so security, we'll select an existing security, and then what are we choosing? We'll use the web security group. Good. Yes, we are good to go. And let's see, advanced network. No, we will not add any network interface. For storage, and also a big right? It's what 8 GB general purpose, something. So we'll come to advanced details, and we'll disable and enable some things. So you know that for us to be able to detect that, okay, workload has changed or workload has increased or workload has reduced, there should be a monitoring service. And then what service does this monitoring? If anybody can help me with an answer. What service does this monitoring to see that, okay, your CPU usage has gone up to this, your CPU usage has gone up to this, your RAM has changed, your RAM usage is up to maybe it's at the peak maximum, or it's at the minimum. What service does that? I'm waiting for answers. Okay, so I'm seeing an answer. Okay, I'm seeing. Okay. Oh, is that all? Yeah, I see another answer. So remember, we are creating this template for auto scaling. I have 3 answers. So where are the rest? Anyway, let me move on. So the service that monitors to check your workload is CloudWatch. So we will enable detailed CloudWatch monitoring. Right. So it is CloudWatch that is able to monitor and say that, okay, your CPU usage has probably reached this per the threshold that you set. So because of that, okay, let me add more instances. So what I say, let me add more instances. Right. So that is what we are coming to enable here. Right. Enable detailed CloudWatch monitoring. So the rest, in fine and we just leave it as it is. And then Boomba will create our launch template. Yeah, so Jason is not load balance. For load balancing there, what it does is that as the load is coming to distribute it evenly. Okay, if you have 2 and then we have like, let's say 10 packets that are coming, right? The traffic load is like 10. Okay, put 5 here, put 5 there. Depend on the health of the instances. If all the 10 is coming and then one instance is not healthy, right? It will send all the 10 to one instance till the other instance becomes what? Healthy. Great. So our launch template is what is created. Now we'll select the launch template. That's fine. That's fine, Jason. That's fine. So we'll select our launch template. We'll go to actions. And then we'll now create an auto scaling group. So now we have created the template. So now we are putting it into what? An auto scaling group. So hey, what name did I give to the? I gave it lab ASG. Auto. Okay, I did. So let me see lab. This one, let me type it in for because it looks like the other one. I did lab ASG. Lab AS. Okay, so I'll do lab ASG. So lab auto scaling group. Correct. Okay, so this is it. And this is the launch template. So this is the launch template that we created. And so the name now, next. For the VPC lab VPC. And then for this subnet, we'll do private subnet 1 and private subnet 2. So what we are saying is that we are just following this architecture. Okay, you can see that the new load that was spin up was what? The new instance that was spin up was spinned in what? You can see here. Okay. And then the new ones were spinned in private subnet 1 and then private subnet 2. So the architecture image has been given to us. So we are just doing as we are supposed to do. right? So this is it. So when you are spinning up a new instance or new instances, spin them into what? The private subnet. So private subnet 1 and then private subnet 2. Good. So this is what I've done. Private subnet 1, private subnet 2. Right. So define which availability zone and subnet your auto scaling group can use in the chosen VPC. Next. So here we already have a load balancer that we created. So for load balancing, we'll attach an existing load balancer. And then we'll choose our load balancer from our load balancer target groups. So this is the target group that we created. So what we have basically done is that okay, so when we were creating the template, we left the user data side without the script. Good. Does that mean the new instances are not going to run the script? So we realized that the web server instance was created for us already, right? And then per the architecture, you can see that it is what? A database server. You can see an RDS here, right? It's a database server that is serving an application. Okay, if you can see from here, it is a database, right? An application that has a database server in the private subnet. So it is not basically let me say a web server entirely. Okay, and then for the auto scaling group, we are creating it for the database servers, not the web server itself. You get it? And even if you are creating it for the web server, the user data script was right. This server, web server 1 was provisioned for us already. So it might be possible that the user data was added to this server for it to bootstrap. So that's why we created the image while it was running. So there is no need to add the user data again. You know what I'm trying to say? So that's why when we're starting the first, we did the first one, we can ask the question that it means that after running the Apache, we can just go and copy any HTML script and then come and dump it in there. So in the user data section, we don't even need to copy those scripts of the Apache, installing the Apache this thing again, because it might probably include in the initial setup. Okay, so we just need an HTML script. If you have any other script that we want it to run, then we can paste it in the user data script, because we are creating this from an image. We are just trying to let it to emulate whatever is there. You get it? So you don't have to, especially when you're creating from an image. The reason why you create an image from a server, or from, let's say, yes, a running server, is just because everything that is there, you want it, and you don't want to go over installing. So let's say you have a corporation, and then you have to install Microsoft Word. You have to install let's say, an antivirus. You have to install what? Like any other application that you use in your work environment. So instead of you running the OS and then you do the installation one by one, you can just run everything on one PC, create an image, and then now install it across all the computers to ease your burden. Great. Okay, now well understood. So I've selected my target group, right? Yes. So I've selected my target group, and I'll leave this one. There is something that I have to check. Yes, so enable group metrics collection within CloudWatch. This one, right? So this will also enable CloudWatch to collect metrics. So I was explaining something. So what we are saying is that, so initially we're supposed to register some instances into the target group that we created. But because the instances haven't been spun up there already, we just left it like that. So now what we are telling this auto scaling group to do is that when you launch these instances, put them into what? This target group. And already we have linked this target group to the load balancer. So you can see that, you see, the target group is what? Lab group, which uses the HTTP protocol. And then the application load balancer for this lab group is what? The lab ELB. You get it? So what we are just saying is that we didn't specify or register the instances in the target group. Okay, however, this auto scaling group, when you launch new instances, put them in this target group. And then since we have already linked this target group to the load balancer, it means that the load balancer will automatically distribute the load across the instances in the target group. And you can also enable health checks. So what the health checks do is that the load balancer will now check the health status of the instances in the target group and say that, okay, this one is not healthy. And then it will send that message to the auto scaling service. So what the auto scaling service does is that immediately they get that status, it will terminate that instance that is not healthy and then spin up a new one to replace it. So that is what the ELB, that's one thing that the ELB also does. Okay, when health check is enabled, I beg.
I'm coming to do. Come closer. So you see it. And you mean Salah. Then up sorry.
I beg mute there. If you okay. Right, so the ELB health checks, as I said, what it does is that when it's deems an instance unhealthy, the first thing it does is stop distributing traffic to it. Okay, but if this feature is enabled, it will now tell the auto scaling service that, listen, this instance is not healthy, so do whatever you are supposed to do. So immediately the auto scaling group gets that message, it will automatically terminate it, right? It will terminate that instance that the ELB says is not healthy and then replace it with a new one. So it will spin up a new one to replace it. It will not add another one. You get it? If it is not healthy, it will not just add another one. It will just remove it and then replace it. So if it was 2, you will still have 2 using the launch templates that you gave it. So if you read here, it says what? The ELB monitors whether instances are available to handle requests. When it reports an unhealthy instance, EC2 auto scaling can replace it on its next periodic check. I hope you people understand. But it's an optional service, so you can choose to turn it on or off. Okay, but you make her turn it off so that, and whatever service that it spins up, it has a cost that comes with it. So, all right, so we'll go to next, and then this is where you enter your desired. So let's say my desired is 2. Hey, my desired capacity is 2. My minimum is 2, and then my maximum is 6. Right? So desired capacity is like, okay, normally I want to have 2, right? So my desired and then my minimum is 2. So always I should have 2 instances available. I should have 2 instances available. And then my maximum capacity, in case there is like more load, but the maximum should be 6. Okay. And then I will use target tracking. Okay. If you put it to none, it means that there is nothing to target. So the target tracking is more or less like how many instances are being utilized, like the capacity. So if there is 1, okay, there is 1, and then it's almost full, then add another one. Somebody I say just add another one. So you say choose a desired outcome and leave it to scaling policy and then add or remove capacity as needed to achieve outcome. Okay, so with target tracking, load are increasing. How many instances do we have? We have 2. Oh, then it means it is still within the, it's a minimum capacity. So add more. There are other ones that you can do. When you use target tracking, you can do CPU utilization, you can do average network in bytes, you can do network out in bytes, you can do the application load balancer request per count target. But we'll keep it at what? CPU utilization. So immediately the CPU utilization goes up, then the auto scaling will do its work. Okay, as to adding new instance or removing instances. For the target value, for it to be fast, let me put it at 40. Or maybe 20 because all the 260 I check. Maybe 20. Right. So if my CPU utilization goes up to 20, then boom, auto scaling should do the work, should do its work. Okay. Yes, I'm fan to 20. In the labs, they say we should put it at 60, but I check too much. So let me put it at 20. So next. So for notification, right? You can add a notification, it's optional. So this one, anytime there is an auto scaling activity, you will receive an email, right? Anyway. Right. Anytime remove. So anytime you receive an email, you receive a notification that okay, there's an auto scaling activity that has gone on. So you have to create a topic, send a notification to maybe my something email, and then you put the recipient's email there, right? But I don't know anyway. It's optional, so we'll leave that one as well. So next, this is tags, right? To organize your distance. So let's add tag. So we'll use name, and then we'll say lab instance. Just to organize them, right? So yes, any new instance that will be launched, it will be tagged as what? Lab instance. A, and then MIOI. Right. So the next is our review. In review and share. If everything is okay, then we'll create our auto scaling group. So choose launch templates, lab ASG. That's the auto scaling group name. The template is what? The lab auto scaling template that we created. And then the description, the network is our lab VPC, availability zone, the subnets, and the instance type requirement. So this auto scaling group will adhere to the launch template. So yes, per the stuff that I selected. And the load balancer is what? The elastic load balancer. And then the target group is the lab group. Health checks is for the EC2. So the EC2 health checks. We didn't enable ALB health check, right? Additional settings, we enabled monitoring. And then we didn't allow instance. So the group size, desired capacity is 2, minimum capacity is 2, maximum capacity is 6. The scaling policy is target tracking, right? And then it should utilize what? The CPU utilization. And then what again? Okay, so great. So we are good to go. Create auto scaling group. So our auto scaling group is created. The capacity is being, so you saw the status here. I don't know if you people saw it. It says what the capacity is being updated. Okay, because we said our minimum capacity should be 2. So what we'll do is we'll go to instances, And then we should see 2 new instances launched. Okay, so this is it. We can terminate this. We don't need this one again, right? Because this is not part. We just use this one for our image, right? So if you see the architecture, the final one, there is no web server here. Okay, we use this one to create our image. And then the final one, we removed the web server here. You bet me terminate way. In here. So terminate. If later we need it to any itiati, we have to create it again. But yes, I'm sure we don't need it, right? So we have our 2 new instances launched because per the auto scaling group that we said we need what? 2 minimum, right? We need 2 minimum instances. And then those are our desired capacity as well. Let's go to our target group to see what we have there. So target groups, let me refresh. If I select now, I should have, see the details. Okay, I think the instances are still launching. But we say total targets, everybody has say the number of healthy ones will be unhealthy ones will be near the other. So let me give it time. I mean, share the instances to see that. Okay, it's still initializing. So you can bring in your questions anywhere, anybody that needs clarification. Now may answer whilst we wait for the instances to be ready. Or can you do all bed? You can't even dropped off. It was complaining of light. Anyway. Okay, so we have 2 out of 2 checks on this. So let me go to the target group again under load balancing. Select, and okay, so the 2 targets are all here. So when I click on the targets, I'll be able to see the 2 instances that that has been launched. Okay, so that's the beauty of auto scaling, right? So we just do the auto scaling to just dump the instances into this lab group. Sorry, this target group, and then it has done it perfectly for us. And then the targets is 2, and they are all healthy because they are now ready. Okay. You can also check the distribution of the targets by availability zone. So you can see that it's put 1 in the US East 1A, and then there is 1 in the US East 1B, right? Let's go to the load balancers to also see. So lab ELB, and we need something here, the DNS name. Okay, we'll copy this. We are coming to do some exercise on our database server. So we'll copy the DNS name and then open it. We just want to see if it is working. So yes, we have. So the current CPU load is what? Is 0%. So it will always maintain the minimum load as far as the CPU utilization is below. What was the parameter that we set? 20 is below 20. All right, great. So now we'll test the auto scaling to see if it is working. Okay. So what we'll do is that we'll go to CloudWatch and call CloudWatch. And then we'll go to all alarms. So for all alarms, 2 alarms will be created for us, right? So alarm high and then alarm low. The alarm high will alert us or trigger an action when CPU utilization goes above 20, right? And then the alarm low will be triggered when it is what? Less than 18 for 15 data points. So now we'll stress or we'll try and then make something happen. So we can see there for alarm low, there's not much data because CloudWatch takes the data. I think there's a 5-minute interval, so said there, right? Okay, so now let's go to our DNS server and then just do a test load. So here it will do, so you see auto refresh in 5 seconds. So what this one will do is that it will just give the database server some activity. So every 5 seconds it will refresh. Every 5 seconds it will refresh. So our current CPU load is 100%. So let me refresh this alarm. And you should see in alarm, right? Say if the CPU utilization like kwana broswa, you should see in alarm. I mean click alarm win. I mean share. We'll be able to see the current CPU. In terms of current CPU utilization, it was 6. Okay, so let me put it. Okay, we cry in chair or let me come in to 10 so that baby and 10, right? So my main course is on. Let me go to my EC2 again. My pentem over 11. And let me go to the auto scaling groups. This one. Or is the automatic scaling? We should see. The target tracking policy. Action. Edit. I'm in to 10. Update. Good. Go back to CloudWatch. All alarms. Master San. Let me do it again. Let me close this one. And I'll do it again. And so say immediately I stop there, the alarm low is also okay, is in effect because the load like must stop load, you know, right? So I'm just trying to see say the stress is agile. Okay. So now let me load. I just want to see in alarm, and then we'll go and check our auto scaling group to see say if more instances has been added or if I'm saying it's still what it is. Okay, so I think we have one in alarm. Oh, it's gone. Yes, so we have alarm high. The value is what? Greater than 10 for 3 data points. So we are going to see, say, if new instances has been launched, right? So let's go to instances. We are in share. So you can see that we have what? All the 4 instances launched at the same time. And this one is even pending. So 1, 2, 3, 4. Right. Now let me close this. I'll close this one so that form, right? The CPU utilization will go down. Now I should say if the auto scaling group will automatically delete or terminate these instances. Okay. I'm inclusive way to stop. And then let's go back to our CloudWatch monitoring. So alarms. So this was the alarm high. Let's wait for small time. So the alarm low will be when the utilization is below 8. Okay, that's fine. So let's wait for some time. That's the last thing we are doing, and then we are done. When we are done, we just terminate our instances. All right. So while we wait, let me just go over what we did for the elastic load balancer and the auto scaling group. So first, for you to create an auto scaling group, you need to have an image and then a launch template, right, for your auto scaling group. And then to also create a load balancer, you need a target group, right? There should be a target group that the load balancer is pointing to. So what we did was to first get an image, create an image from an instance, for a running instance, an instance that we want to replicate across our availability zones. So we just created an image from it and then created a launch template for the auto scaling group to use. Now, we first configured our load balancer by first creating a target group without an instance registered to it. As I said, on a normal circumstance, if you create a target group, you have to launch, or you have to register instances, running instances in them. in order to be able to link the load balancer or to forward or point the load balancer to. So the load balancer listens from a port and then distribute the traffic across the instance in the target group. Now, because we are going to use an auto-scaling group for our instances, when we created our target group, we didn't register any instance. Okay. We now created the load balancer and then forwarded or created a forward point to the target group. The next thing was to create the launch template for, our auto-scaling group by using the image, selecting the instance type, storage, and then all that. That was the launch template for the auto-scaling group. And then we now created the auto-scaling group by specifying the desired capacity and then the minimum capacity and then the maximum capacity. Okay, so that's what we told our auto-scaling group to do using the launch template that we gave or that we specified. And then now we say that, okay, when you create these instances, either minimum or maximum, dump them or put them towards the target group. And this target group is being pointed to by the elastic load balancer, right? And then we now also set parameters for the CloudWatch to monitor that in case the CPU utilization goes above a certain threshold, then launch my maximum capacity, right? If the load or the workload reduces or goes below that threshold, then launch my minimum capacity, which is also my desired capacity. Oh, let me go and then check the alarm high. Let me see. Okay, so it's still at the top. Still at the top. So what I can do here, let me see the number. It is 99. I wanted to go and change the utilization value again. Okay, so let me go back and then go and change it. So yes, so that was basically it. And then the rest was just to monitor to see that if the load balancer, the CloudWatch alarms and everything was working. So that was why I was tweaking the values to see what is happening, right? To just to expedite things for us to appreciate what. Okay, great. So the load is, you can see that it has drastically reduced, right? And then currently it stands at 11. So let's wait for a while. So this is the alarm low. Within a short time, you will see that the alarm low will be in alarm, right? So at this moment, we are still in the alarm high. So we have our 4 instances still running, right? So let's still wait for some time. As it has reduced there, it will go down very soon. So immediately it goes down, you see the alarm low now in alarm, and then the alarm high will just be okay because the load is down. Okay, this thing. So let me go and change it to 20 because it looks like a call up and down, So it is between 14 and 30. Okay. So let me put it at 50. Right? I'm in Fanco to 50. So I'll go to my EC2 again. Auto scaling group. what I just want us to get is to just appreciate how the auto scaling work. That's why I'm trying to tweak the numbers. Let me open the CloudWatch first, in case it happens that I don't even need to do it again. Alarm. Is it the alarm low? No, still the alarm high. Okay, it's gone up again. All right, so let me put it at I'll put it 100. Auto scaling group, lab ASG, auto scaling, and this action edit 100. Okay, update. Good. Says insufficient data. Now what I'll go to my instances, and so I have great. So okay, so the alarm high is okay. Let's wait and see. $64. So immediately it gets the signal or the alert. It should just start taking off the launched instances. All alarms should be below 90. Okay. How can you drop off?
Yeah, Charlie. Today I already sit up at tire. My phone go off, so I forgot put them for charge again.
So this alarm is also okay. Right. I mean, share instances, no. So it should start. Okay, so now since it has the data now, it should start terminating them. It should be in alarm and then start terminating of them. I think it takes the data for 3 minutes. Oh. Then can't I change the interval? Okay, we cannot edit restrictions. I wanted to change the time interval. I didn't read the time. Let me see. This is 23. Adeɛ baako yɛ abrɛ saa. And this is like part of the whole thing, because if you are working for somebody and then you've made some configurations, you would want to make sure that it is working. So if it should take you the whole day to monitor, then you should do that, right? You should do that to make sure that okay, whatever you are doing is in check. Utilization within 15 minutes. And we're here within 3 minutes. Oh, how? But it's coming down. It's here from Kora. Well, so it means that the alarm load takes a while. But if I had used my account, I should be able to like edit as to the tracking times and then all those things. Like I should be able to, yes, it's 15 minutes. Like I should be able to do the tracking, right? To make sure that, oh, this is too much. $15 they aim to maintain. So anyway, if anybody has a question, but I'll leave it on. Immediately it starts doing terminating them. And I'm in so immediately start terminating them. I will send the screenshots to the WhatsApp pages because 15 minutes there will not go feel it. Yeah, there. Even for the instances, they are still. And also we're trying 15 minutes. Oh, minutes and in that auto scaling alarm with target tracking scaling policies. And I'm interested in making me access a time and wow. Design capacity, I made this is 2, 8. Aha. And automatic scaling. Yeah, there's seconds. Stable scaling to scale up. Warm up there should be like that. Yeah, sir. Let me go back to my instances. $50 no reach. But why the alarm high will be 3 minutes per, and then the alarm low will be 15? So I think it's for safety reasons, right? Or say, yeah, and say the next 3 minutes. Because how long does it even take for an instance to be ready? It takes up to like 1 up to 5 minutes. And you say if the next 5 minutes now or the next 3 minutes you terminate it, that means oh senior. So I think that is why. I'm just thinking out loud. So our alarm low is now in alarm. So let's go and check our instances, refresh. Then it will say it should start terminating some of the instances. If I'm going to refresh it. I'm going to show me target group. No? Target groups. So 6 targets. So we want to say draining. So 4 is going off at the moment. Yaka 2. The 6 target groups. And then 2 healthy. I mean, remember. Hey, comment that thing eh? Let me tell you. Alarm low. Let me go to my auto scaling group to be sure, say. Desired capacity 2, minimum 2, maximum 2. Okay, correct. We are good to go here. My load balances. Okay, so we now have 2 left. So why are they still here? So you can see from our target group, we have just 2 left. If the instances are not shut down, then probably there is something that I forgot, that it should rather terminate them, because it looks like once I went 1, 2, 3, 4, 5, 6. Yes. And probably when I was doing my auto scaling or something, there's probably something that I missed. So it takes them off the target group, but it doesn't terminate them. So maybe I missed the setting somewhere. Scaling. Huh? and probably I missed some settings somewhere. So more or less like it doesn't delete them. This is okay. I mean, it doesn't terminate them or something. Lab Autoscaling group. Headlines. So these are other stuff that we also have to check. And yes, if a boy a company car. One, two, three, 1, 2, 3. Advanced settings. Yes, detailed CloudWatch. There was no termination protection. Shuts down behavior. Instance management. Set scaling protection. Let me go back to the instances and see if they are still there. Yes, they are still there. It was just slow. All right, so you can see that our instances, so it looks like the auto scaling, the target groups kind of respond faster than no. Here it's slow maintenance here. When you are even launching them, it's the same thing. So you can see that these the extra ones that were launched are all terminated, and we are only left with this one and this one. And this one was already running when we started the whole thing, right? So you can see that the other 4 that were launched together have all been terminated. So that's the benefit of auto scaling group. So we'll end it here. Can load balancer work without CloudWatch? Yes, so the load balancer has its own health checks, okay, that it does. So as I said, the load balancer can, per its health check, can deem an instance unhealthy. Okay, it can tell an instance that, okay, it can say that this instance is not healthy, and then it will just communicate to the auto scaling group, and then the auto scaling group will replace it. You understand? So yes, you can do your load balancer without any CloudWatch alarm. You only set your CloudWatch metrics when you are doing auto scaling group, that okay, when CPU utilization goes to this, add another instance. So I would say that the auto scaling works with CloudWatch metrics and alarms, whilst the load balancer is just more for, health check, and then just the name, as the name goes, load balancing, right? So per the traffic that is coming and per the number of instances that is available, it distributes the traffic evenly to them. So yes, load balancer can work without CloudWatch, but when you are using load balancer, it's for best architecture purposes. It's always best to include auto scaling. So that is why the topics are always treated together: load balancing and auto scaling. Is are we all okay? Except if unless if people are sleeping. Okay, sure. So I'll try upload the video tonight and then add it. So as I said, the link is the link I shared earlier is a playlist link. So we can all access. When you visit the link, you'll be able to have access to the other videos. So you can just go back and then go and watch them all together. So today we looked at launching our instance and then monitoring it, getting some metrics from it, getting to know what happens like in the system logs, and then also had a screenshot of it. And then in the next session, we looked at extracting or creating an Amazon machine image from an instance, using that to create a launch template for our auto scaling group. Created an auto scaling group and then created a target group for our load balancer. We then created a load balancer and then forwarded which listens on port 80 and then forwards traffic to the target group. The auto scaling group then launches instance based on CloudWatch trigger alarms or CloudWatch metrics, launch EC2 instances into the target group for the load balancer to distribute traffic evenly and evenly to the instances. So we tweaked our CloudWatch parameters just to test both the scaling out and then the scaling in functions of the auto scaling service. So I think if we all try and try our hands on or try and then watch the video and then go do it hands on, we'll be able to appreciate this better. So in the absence of any question, we'll end the meeting here. God willing, tomorrow we'll look at storage. So we'll look at the EBS, we'll look at the EFS, we'll look at the NFS. Huh? Yes, we'll look at NFS. And we'll look at S3. Hopefully, we'll look at S3 as well. And then we'll be done with storage. So that next week, we can now start with SAA. So, good night. Good night, all of you.
Good night, Chief.
Thank you, boss.